in the latest proposal regarding evidence handling, so there is a PR on Tendermint RS repo at informal GitHub. I mean, of course, this will move to the Tendermint spec eventually. But idea was to try to address several concerns. And I would say the first one was this confusion between the main chain forks and light client forks. And I think that this is something which was creating a lot of confusion, essentially with everyone. And so this was, let's say, one important concern. And then the second one was really about deciding where the detection will take place and where we'll turn these, let's say, or how we will proceed after we detect something is wrong. Who would create evidence? They're having essentially we were going back and forward between doing it more on a full node or a light client. So this was the second stuff. And the third one was about amnesia and how we are thinking with respect to amnesia and also relation between amnesia attacks and the other kinds of attack. So I would say these are the three main concerns which with this proposal we are trying to address. So overall, the first thing, and it's related with the first concern, is that we Calum, we agree that we'll call the attacks in the case of light client attacks, and we'll not talk about forks, because forks we reserve more. Yes, this.
Just to be clear, when you say light client attacks, you're talking about like attacks on the light client specifically. Some full node is trying to fool the light client. Exactly. Okay.
And so when we say fork, then we try to reserve the term fork for the main chain. And when we say light client attack, it means some full node or group of full node is trying to fool light client. And now light client detected inconsistency, and then it's trying to react on it by creating some evidence of misbehavior, which can be processed then by the full node. And idea here is that this evidence will be sort of sandboxed. So it will go to the evidence reactor and be processed, but it will not interfere with the main chain process. Cool. And the reason why, I think first the nice stuff are that we are really separating this concern, and this is one use case we want to address, because if we don't do this, then it's always a question, okay, what happens when you have the fork on the main chain and fork on the light client? And this, we don't know how to answer this question right now. So if there is a fork on the main chain right now, we don't do really anything. And we are somehow hoping that it will, that enough number of full node will panic eventually and will halt the chain, and then we'll resolve to some kind of off-chain resolution process, which might involve similar mechanism we have in light clients, but these are the stuff we don't want to talk here and we don't want to address with the current spec, okay? And now if we are focusing only on light clients attacks, then the second important concern was, so we know that there are three kinds of attacks, that there is lunatic, equivocation, and amnesia. And also, I guess it's good always to remind that we did a verification effort together a bit on our side and also together with the guys from Galois to prove that this is essentially exhaustive set of attacks you can do on Tendermint. So we sort of know that if we address those, we are fine. If we don't change the definition of what is, how the light client works. Although the light client part, we haven't, it's more like probably true to say this for like full node attacks than light client attacks. But never mind. Like, let's say that we consider, for now, we feel quite safe to consider these three kinds of attacks. And now what we try to do in this latest proposal is that given light client attack, which is defined essentially by two branches which have a common root, and then they diverge at some height, conflicting height. And Calum drew a very nice diagram where essentially we can illustrate this. So like this is essentially a like line attack. So we have a common header, or we can say common header is 1, and then we diverge. We have 2 branches. At 10, they diverge. You know that we have conflicting headers. And we normally, when we talk about like line attack, we are in a perspective where the like client node is talking with 2 peers. And we sometimes call those peers primary and witness, and we'll see that this is more like a role, and it could be swapped. But for now, let's say that there are 2 peers, and like client is talking to both of them, and figure out that they have a common header, and then at some point notice that there is divergence. And note that essentially once they diverge, they could keep diverging forever. So these, when we say like line attack, it could in theory means like infinite amount or infinite number of headers which are part of these divergent forks. Okay, and so the one important aspect of this latest proposal is to try to somehow bound what form the like line attack evidence, so that it's a bounded in size, because otherwise in an initial proposal we're having a trace of headers, and this is like increased surface attack, because you can have quite few headers in there.
And this is a basic question, but just to zoom out a little bit and make sure that I'm following all this correctly. All 3 of these light client attack types, lunatic, equivocation, and amnesia, they'll all sort of manifest in this way, right? Where it looks like a fork to the light client.
Exactly. And so this is exactly, so we are actually, with this latest proposal, we are trying to somehow unify the view on all 3 of them and to understand what is common and when they diverge.
Cool.
And the first time we also try, and this is something which we haven't done before, that we try to figure out deterministically, given attack, what kinds of attack this is. Mm-hmm. Because I think that it was, for me personally, it was confusing, the fact that you can combine different kinds of attack. And then the question is, what do you do then? Mm-hmm. And so essentially one thing which actually in the proposal I haven't formulated yet explicitly is the fact that given a like line attack, what we want to do at the end of the process is to determine at least more than 1/3 of faulty validators. So we don't promise that we'll catch all of them. We just promise that we'll catch a minimal set of misbehaving actor which led to the fork. And I think this is important because when we go from the like line attack to a particular attack type, we are sort of focusing on that goal. And we are not saying we'll catch all of them, but just we'll catch, let's say, the minimal misbehavior set, so we can punish them and hopefully disincentivize such behavior. Does this make sense up to now?
Yeah, this makes sense. And this, I don't want to like skip ahead or anything like that, but just to catch you up actually on a conversation that Callum and I had with the SDK team. So Corey, who works at Regen, but who's working on the SDK now, about this stuff, because they were like, oh, there's new evidence coming in, what's happening to ABCI, all of that. And the place that we have landed, and that we're like kind of going to try to move forward with them on that, is like just to say, okay, there's basically, as far as the SDK is concerned, there's basically 2 kinds of misbehavior that we can tell them about. One is like a network fork, and the other is an attack on the light client. Mm-hmm. And so we've kind of, at least what we've said we're going to do, and in a pinch we could change it, but what we're planning on doing is kind of wrapping all of those light client attacks, whether it is lunatic or equivocation or whatever, into one like evidence type for them, and just saying like, someone tried to fool a light client, do what you want with this information. And so that sounds really consistent with what you are saying here.
Exactly. Yeah. So idea here is really to try to somehow consolidate there and to have as much as possible unified view on the stuff. As we see, amnesia is a bit special and it requires more handling, but at least let's say the front end work is the same also with respect.
I'm not so sure it's on the ABCI side that we can easily distinguish between a on-chain fork and a light client attack, because equivocation will play a role in both, and amnesia will play a role in both. It's not that these are attacks which are purely on the light client. Lunatic is, but the others are sort of can be in both parts. The question for me rather is, why do we need to tell them the attack? We give them the list of people who behave badly. That should be the easiest, and not, I don't know what is the information that we can give them by telling them how they misbehave.
Yeah, I mean, we don't want to give them more detail than they know what to do with, but but are you saying that for equivocation and amnesia attacks, we won't actually be able to tell if it's an attack on a light client or a network attack?
At the end of the day, if it's an equivocation attack, the only difference whether it's a light client attack or a chain attack is whether a full node has been affected by that or not, right?
But here, idea is really to try to really make a clean separation point between these two kinds of attack. In case of light client, there was like successful light client attack means there was a fork which was observed by the light client according to the light client verification rules. And we want to sandbox this. When I say sandbox, it means that we don't propagate this information, because I mean, at least in case of equivocation amnesia, you could use the same piece of information to halt or to create the main chain. But we don't want to do this. Like we'll see how we'll deal with this maybe later. But for now, we really want to put this in a box and just propagate it through the network without looking inside, let's say. Is
maybe another way to say this, or another related idea, is that like the light client, if the light client thinks it's observed a fork, the only thing we know for sure is that the light client thinks it observed a fork, right? Like, exactly. I guess I just said the same thing twice, but like it doesn't necessarily mean that there was a network fork if the light client thinks there was a fork. And so you can probably, hopefully, rely on full nodes on the network to notice if there is actually a network fork. And so we don't need to rely on light clients to do that, because the full nodes should be able to.
Yeah, I think it makes sense to distinguish light client attacks and network attacks. Also, perhaps on the ABCI, yeah, I think, but it's just not linked to equivocation and amnesia. They're just sort of, they are more about the effect, what the attacks have, rather than the reason. And amnesia and equivocation are the reasons and not the effect.
Yeah, but the point here, and this is exactly the reason why we are calling this light client attack, and then there is lunatic light client attack, equivocation light client attack, and amnesia light client attack. So we are giving a bit of flavor to the attack, so that essentially this evidence can be validated, whether it makes sense or not, and also the post processing can be adapted.
I totally agree. I just had at some point in the conversation the feeling that there was a belief that equivocation is linked to a light client attack.
No. Here, idea is really, we just want to say, as I agree with Tess here, that we know there was light client observed something which looks wrong, and according to the light client bisection essentially rules, or light client verification rules, we are really seeing two branches which satisfy the light client verification spec. And important thing here also to keep in mind is that application also wants to be informed only about bonded validators. So this additional requirement. And this is where actually it's nice that as we rely on the verification spec, it will not give us two branches which form light client attack if there is no enough bonded validators between the common light block and the conflicting light block. We know that there is at least there is more than 1/3 overlap there. So there are some bonded guys. Actually, there are more than 1/3 of bonded guys, which could be slashed. So I think that this is also kind of important observation. Okay, and now essentially, let me just see where we are. Now the question is, what can form a like line attack evidence, or how we go from this case where we have potentially, let's say we started from a trusted header and we consider a primary and witness, and so primary is trying to verify age, and then it goes through these intermediary headers or blocks, and then after we verified age, we then try with witness to see at this height what are the headers witness has, and we see that there is something different here. Now the question is how we go from this trace A to H, and the fact that now witness is telling us that I have something different at this height, how we form what we call like line attack evidence. And idea is that, as we said, idea is that we don't put a trace there. Idea is that we put something of constant size there. And so like what we have in this proposal is essentially that we consider always, it's a two-peer and like client game. And like client considers what we call primary. So we have a trace which is under suspicion, say, because there is a conflicting one. So we say, okay, this trace, which is provided by primary, is potentially faulty, and witness is correct. And we try, in that case, to build a minimal like line attack evidence. And the way how we do it is we consider the like line, the primary trace, and we interact with the witness by following the heights which were part of the B section going from A to H on primary. And we try to do the like line B section with witness by following essentially those heights.
And who is executing this verification process? Is it a full node? Is it
It's
the like client? It's the like client, okay.
And the full node is witness who is participating by answering to the queries.
Right. Okay. So this is the part of the sort of like evidence lifecycle where the like client has like seen something funky and it's now preparing this like evidence object that it's going to.
Exactly. So okay. Yeah, in this proposal, we are actually pushing the most of responsibility on the like client, and we just expect full node to participate. By normally it's being queried for like blocks or for headers and validator sets. For signed headers and validator sets, what we call like client. Mm-hmm. And so the like client will actually now ask witness to provide. It will actually try starting from, in this case, maybe it's better we look here because we have numbers. So let's say that on primary trace we have 1, 4, and 10. These are the heights of like blocks. And now we are trying with the witness to find this what we call minimal, sometimes also minimal bifurcation point. And so we start from 1, this is what we trust, and then we ask, with the witness, we try to bisect until 4. And so in this case, there is a direct, you can directly skip there. So we go to 4, and 4 is the same at both primary and witness. So we continue the process. Then we ask for, we try to go from 4 to 10 in this example. And on the way, we'll see that there is a 7, and 10 will be divergent one. So we managed to, with the witness now, to build a different trace, starting from a common header, which ends in a conflicting header. And now we know that witness has 1, 4, 7, and 10. And on a primary, we have 1, 4, and 10. So what is the minimal information we need to provide to the witness so it can essentially have the notion of like line attack, which it can verify? We need to give the 4 as a height number of the common block, and we need to provide a 10, which is a conflicting header on the different peer.
And okay. Who is the like client providing this evidence to?
So like client is sending this information to the witness.
Okay.
Because in this game, we sort of, there is always a trace which is kind of under suspicion, or this peer is under suspicion, and we assume that the other peer, which we call normally witness, is participating in building like line evidence, like line attack evidence. And so like we somehow assume that the witness is on a correct branch, and it's cooperating, it replies to our queries. And then by talking with the witness, we are also kind of discovering what witness knows. So we know what is the minimal piece of information we'll send. And so once we send it to the witness, we send 4 and the conflicting block at height 10. Witness can verify this because it has a 4 and it can do the like line verification from 4 to 10 to see that this was indeed possible conflicting header and that we had something different at position 10.
Right, and so this requires that the witness is behaving correctly, right?
Exactly, yeah.
Okay.
And also like, so it should behave correctly and it should be on the correct branch because the witness will, as part of evidence reactor, it will gossip this information to other full nodes, which should do the same thing. And so we are somehow assuming that these full nodes are on the same branch. So they have the same
other branches.
That they're on the exactly one on the correct branch, let's say. And now also what is
so the main advantage here is that once we submit this evidence, the full node has just to verify one block, right? While
yes.
in the other one there was this unlimited traces, and it would have. So this is the main difference, right?
Yes, exactly. And also the important thing here, which also we haven't explicitly mentioned, is that why we are also chasing this let's say the earliest bifurcation point, because this is where we are sure to catch the bonded validators. Because if you have a long like you have a branch which diverge quite a lot, and you only catch the conflicting header at this height, H and Y, the Y could be signed by the validator sets which are not bonded. Because at the bifurcation point here, going from C to E, potentially the validator sets has changed. And then at G, it's completely different validator sets in the worst case. So now at I, these other guys who are, it's a set of validators which are, or processes which are not really bonded. So it's really critical for us that we define like line attack, making a minimal, this one-step verification jump from the common header. Because only in that case, we are sure that we have enough, we have more than 1/3 of bonded validators. And then like line attack evidence, when we process it, will read to the slashed validators. So it's not only about, let's say, the constraining the trace to be of size 2, because this is essentially what we are doing. It's really about defining one step, the bifurcation point, starting from the common header, because this gives us certainty that validator sets will overlap, and there are guys we can slash for.
There was, I put a question in the PR. Now, in principle, now when we have all these blocks, there can be many validator sets, right? The question is which one we're going to intersect with the one we report, right? In principle, you could, because I think in your proposal you would, I don't know, do a
depends on the kind of attack.
Of C and H, and then to the intersect.
Depends on the kind of attack. We can go this after
okay.
in more details when we talk about each like line attack. So at this point, I think it's just important to kind of to keep in mind that if we form like line attack, let's say we take this example. So like line attacks, in this case, what is sent to witness is 4 and 10. And what the full node, which is correct, which is we call a witness in this case, what it knows that at 4, there is, let's say, it knows what is the correct block at 4. And it knows that, 4 is, we assume that if you can do the like line verification from 4 to 10, that the guys at 4 are bonded. And therefore, there is overlap between 4 and 10. There is more than 1/3 of correct guys there. This is a minimum thing. This is what you know for sure. Now, what is the overlap between the validator sets at, let's say, correct 10 and conflicting 10? This we don't know. there could be essentially no overlap. Because here we have 7, so a 7 could essentially kick out, it can change completely what you just said. So these guys, but from 4 to 10, we know that there is overlap, okay? And now this essentially.
Wait, before I just add a comment at this point here, because this procedure here, we are actually doing in both directions, right? We're going to take the primary, secondary. So therefore, I don't like the naming here, because what is primary here will once be called with the secondary, right?
Sure, but like I'm not yet there. I wanted just to motivate with what we have right now, to motivate the why like-line attack evidence data structure contains only a common height, conflicting block, and a type. So I haven't yet explained what we do after. So like essentially we are still defining what is the like-line attack, and then we'll talk about the procedure we really do to create at both sides the light attack evidence. So like is it fine to say that? Are you following me when I say that the like-line attack evidence, we can define it by saying this is the common height and this is a conflicting block, and it has a type. We'll talk next about type.
And I think we also need the witness there, right? Or if we need the information.
It's more, we might need it as part of the process, but we probably don't want to put it inside the evidence, because the full node will disseminate this after. So it's only like if you would put a peer, it would be the peer ID of the witness, but then it's not really very useful information because later you're disseminating this evidence.
And so the idea is that from this like pretty minimal evidence object, that's just like the conflicting header and the attack type and one other thing, which I don't remember now, but when it's just those 3 things, the conflicting block, the common height, and the right. Exactly. With just that information, the light client can pass that off to a full node, I guess the witness, and then the witness and any other full node can like reconstruct the necessary information about like validator sets and things like that in order to actually pass that information across the border to like an application that would then slash or whatever.
Exactly. And now the important thing here is that now given this information, which are, so we also haven't explained this attack type. We know that there are 3 of them. And now the question is how we decide at a like client what was the nature of the attack. And so essentially there seems to be a deterministic way of doing this, and it's actually captured here. And this is the isValid function, which is executed by the full node that receives evidence, but it actually also defined more or less what conformed the like-line attack. And,
can I ask a question?
Yes.
Why do we need to do this at the light client?
Why we are, you mean why we annotate this stuff at a light client?
Yeah.
As it's super simple, we in principle don't need to do this, but we can. And like the more costly part is actually to do this procedure of defining like-line attack evidence. But we could also do it in a full node. Like I don't know. I think it's just convenient to have one data structure which will be defined and shared between like-line and full node, and then like-line create this, and then the full nodes are just verifying this. Maybe this is the only explanation. I don't know, Calum, if you have something to kind of comment on this.
Yeah, my only comment would be like it's important if it's important that the blockchain, the network knows what type of attack was performed. So if it's not, then perhaps it's not necessary to have this. Because like this is there's nothing that falls through these gaps. It's either valid, it's either not valid, or it's valid and the commits in the same round, or it's valid and the commits not in the same round. So nothing falls through this. So it's like technically, if we were not caring as to what kind of attack, like because these sort of different types of attacks are just the way with which they fool to the light client. At the end of the day, they achieve the same end result, which is fooling the light client. So if it's not important with what method they use to actually fool it, then actually this sort of like verification probably isn't necessary.
Yeah. So now if we can just go quickly to these three kinds of attacks, so we see this logic, because at some point we might need to do this, because I think currently, at least in ABCI, we are providing this information to the application. We say this is the validators which misbehaved, and they did like equivocation, or they did, I don't know whether we want to do this, but like we can, let's say, if there is a value on the application side of knowing what was the nature of attack, because maybe the slashing rule is different, we could do this. At least it's important to say whether it was amnesia or not. But so lunatic attack is more or less defined as a like client evidence, which is valid. So we have essentially we have this check that you can go from the common header to the conflicting block. You can using like client valid and verified method, and of course the conflicting block is different than what exists at the blockchain at that height. And after this check has been done, then we can look only at conflicting block and the trusted block. So these are essentially, if you go back to this diagram, these are.
So actually, what this function is doing, it's on the full node, right? Because
yeah, it's on a full node. Yeah, exactly. I'm just trying to somehow explain the. I think that it exists also. We have it here when we create evidence.
Yep.
We can maybe look it also here, but it's essentially, maybe it's more, I was trying to kind of explain first the nature of these attacks, and then explain briefly how this works here, but we can also look directly here. It's the same thing. So we just have two blocks. One is the conflicting block, and the other is what we consider trusted. So it's a trusted from the perspective of witness or peer we are talking to. Like here, like client has this trace and essentially has this one, and this one, it is creating the like line evidence for this one, so it consider it trusted. So the 10 will be a trusted block, and this 10 will be a conflicting one. Okay, and now if what is the conflicting block, if it not valid, and the block validity in this case is defined by the trusted header. So these are the guys we trust, because it is helping us to create like line evidence. And so this one is conflicting. And the validity is defined by the header on the trusted trace. And it's actually, in this case, validity is defined only with respect to the fields which are validators hash, next validators hash, consensus hash, up hash, and last result hash. So these are the fields which are actually created by the application, and they are coming from they are defined by the essentially executing of transactions from the previous block. So if you have a block at height h, and you are now building a block for h plus 1, you have several options there. Like you can have different transactions included. There are several fields like timestamp. I think there are many stuff which a last commit could be different, but these guys must be the same, because deterministically, when application execute a block, it always should output the same set of those fields. So if it's not the same, then we are saying this is a lunatic behavior, and we have a lunatic attack. And at this point, if you have conflicting block, which is not having these fields valid, then we don't need to consider any other kinds of attack. This is clearly for us lunatic attack. And we don't care if potentially there was some, I don't know, equivocation or whatever, because we know that there was more than 1/3. If you look here, for example, there was more than 1/3 of the guy which were bonded at 4, and now they sign something which is completely invalid from the point of view of this 10 here. So they are lunatic, and this is sufficient for us to slash such behavior.
Just a minor clarification on something you touched on earlier. You said it was. You said it's beneficial to notify the application of which type of attack. So currently in the ABCI yesterday, it was implemented that we just notified that it was a light client attack, but not which light client attack it was. Do you see that as like a detriment, or how beneficial would that change be?
So it doesn't. We can provide more information than this, so there is no problem there.
I think it maybe also is worth drawing the distinction between what information we're passing over ABCI back to the application versus what information we need to pass around, like at the Tendermint level, right? Because maybe at the Tendermint level, we want to pay more attention to, you know, whether it was a lunatic attack or an amnesia attack, but the application does not really care. I mean, honestly, at this point, from talking to the SDK folks, they don't actually care at all, like what kind of attack it was. Like if something went wrong, they're just like, okay, slash them. Like it's all the same. And that's kind of where the SDK is at. So any more granularity we can provide them is like not, I mean, we can do it, but I don't think it's going to be that helpful to them at this point.
I think it's important here, and this is what we, so I try in this proposal to separate this evidence creation and then this validity check from this essentially evidence handling, like what happens if there is this evidence, and so like this is more or less correct. This should correspond basically to this ABCI interface, because I have at the Tendermint like client attack evidence. I know it's valid, and then based on the attack type, I decide what are the validator addresses I will output it to the application.
Got it. So maybe one way of breaking this down would be to say that there's like the evidence creation process, wherein the light client is like checking its traces and gathering headers and all of that. And then there's the evidence handling piece where, you know, a full node is actually taking that evidence object, figuring out like who the misbehaving validators are, and then passing that information across the threshold to ABC, like across the ABCI threshold to the application.
Exactly. And so if you talk about lunatic attack, then the way how this handling look is that if I manage to check that, let me just see. Essentially here we know that the like client attack evidence is correct, and I'm missing this because I think that I haven't just quickly refresh it because sorry guys, I was making some changes here, but okay, never mind. So we assume that like client attack evidence is valid, and there is this validity function defined above, and that it's a lunatic attack. And now how we define the misbehaving nodes? Essentially, all is done before, because we know that it was the valid like client attack, and that we checked because lunatic attack field is checked as part of validity function. So we know that this is something we can trust. So now it's only how to decide what are misbehaving are. And in case of lunatic, we need to these intersections Joseph was talking about. So if you look here, we have 4, which are, this block is part of the chain, the correct chain, and there are bonded processes which are defined by this block in a validator set and next validator set. So both of these are bonded because these two sets can be different. And also the validator sets which are part of 10 are also bonded. And so this defines us let's say the sets of validators which will intersect with a conflicting one to decide which one will slash. And so this is captured here by this logic here. Because essentially important here to keep in mind is that validator sets which assign this getter and validator set assigned this one could be completely different. Because they are lunatic, you know, they are ignoring the validator set, so they can choose whatever validator sets they want, such that there is 1/3 of overlap in 4.
But since this is computed by full node, how expensive would it be to union over all from 4 to 10?
It's not 4 to 10. It's only at the 4. At the blockchain level, we have access. We are actually writing validator sets for each block to the database, if I'm not wrong.
Yes, the question is if I can make this operation here, and it says get validators 4, get next validators 4, get validators 10.
Yeah.
But I could in principle do all from 4 to 10, right? The question is how expensive. This was my question: how expensive that would be? Why
you want to? Okay. You want to know all the validators which were between 4 and 10, and then you intersect all those sets with a guy at 10.
Yeah, so it could be possible to do that here, right? At this point, nothing.
Yeah, you're right. Yeah.
I'd also like to just come in with a comment here, which we were discussing with the Cosmos SDK, which is that as important as it is for Tendermint to identify these attacks, it's up to the application about what they do with them. And so what I mean by this is that it should be up to the application about whether they should slash them or not. So we should be able to just give them all the validators that were part of this attack, and then they decide. They do the logic about whether they who should be slashed, and we shouldn't really spend so much time worrying about whether they're still in the validator set or not.
I think what Joseph is saying is that so in this proposal, we look at the validator set at 4 and next validator set at 4, because these are the guys which were used as part of the verification logic. So the intersection between 4 and 10 actually made attack. So we know that there are more than 1/3 of guys there. And so we can actually, this is sufficient. So if our goal is just to give a minimal one, we don't need to provide additional one. So what we have in addition here are the validators at conflicting height, because this is kind of, let's slash more, because there are some which are not here in overlap, but they are kind of doing bad stuff. And then Joseph is saying, why not going from like every bonded validator set from 4 to 10? Why just, doing it at 10? But probably the correct thing is that we only do it for 4, and we don't even have this stuff for 10, because if our goal is let's just provide the minimal, more than 1/3 of misbehaving guy, then we should probably stop here at the validators. I'm not even sure we should do next validators. Depends how the verification logic is done.
I guess it should be next validators, because this might be the ones that actually wrongly signed, right? Because for the light client, for the intersection, you're using the next validators to go from 4 to 10.
Yeah, but like when we do the verification, like given a block at 4, when we do the like line verification from 4 to 10, we are using validator set, not next validator.
Next validator set.
Next validator. Okay, then it should be next
And
validator.
the Go button there. Am I muted? No. The Go implementation is current validator set, not next validator set.
Okay. So
no, I think there's something. There's something. Yes, but this is one. Yes, yeah. I looked at this once. Because
I think both are fine. I think both are fine, but we should just agree which one we'll use. So there's one of those is sufficient. So I think that I will remove this conflicting height, and we should agree whether which one we'll use. Let's say for both Go and Rust implementation. So we don't forget. Okay, cool. So this is lunatic. And so
I would like to add something, because the comment about the Cosmos SDK. So I had a chat with Ethan a couple of weeks ago, and there it seemed very strict that we can only report bonded validators over the ABCI. So I'm a little bit surprised that they now say they don't care about that.
No, they don't. They do care about the. I think that they do care about them. They need to be bonded, I think, because they don't have a way to check whether it's bonded or not.
Okay, just as like a general question, the concept of bonding, is that something Tendermint specific or Cosmos specific?
It's the evidence age.
Yeah, okay. But is that always the same? Is the evidence age
It's evidence block height and time, because we implemented hypertime, and so the length at which you can submit evidence is basically your unbonding period, because that's at the length you can slash someone.
Yes.
So it's actually, it's in the consensus state, which is Tendermint. So it's not Cosmos specific. Every Tendermint based chain can specify the unbonding period.
Yeah, okay. The concept should reside in Tendermint about this bonding and unbonding period.
Yes.
Okay, cool. And so this was lunatic, and now if valid block is, so if the conflicting block is a valid block, so now we know that these fields are the same in both conflicting block and the trusted block, then we have two cases. Either, let's see where we are. Either the commit round is the same, and then it's equivocation attack, or if it's different, it's amnesia. And now the important, like, there was a question also on a PR, like, yeah, but like amnesia attack could involve equivocation. And so like important, the reason why we can distinguish this is first, note that if it's a valid block, this means that those fields are the same, which means that the validator set which signs conflicting block and the trusted block are the same. And they essentially sign as they are the same set and there is the same commit round and the blocks are different. They essentially produce the same set of validators, produce more than 2/3 of commits for block A and 2/3 of pre-commits for block B. So we know that there is more than 1/3 of misbehaving guys there. Because otherwise you cannot create two conflicting blocks if you don't have misbehaving, more than 1/3 of misbehaving guys who are equivocating. So if commit round is the same, we don't need to go and inspect whether there was amnesia involved, because we can slash just based on equivocation, and it's much cheaper. Is this kind of clear to everyone, or? This was kind of an important insight that we can define something we could call pure equivocation attack just by looking at pre-commits if commit round is the same.
I mean, we can define it's pure, but it doesn't mean it's pure.
We have sufficient number of evidence to slash more than 1/3 of guy.
Yeah.
You can do more, bad stuff, but this is sufficient so we can slash it, and Tendermint can validate and say it's indeed it was indeed attack. Okay. Now, if the commit round is different, if the trusted block and the conflicting block has a different commit round, then there is no simple way to say what are the misbehaving processes. And this is where you have amnesia. So just regarding evidence handling, if you look at the equivocation, it's also kind of very simple. So like as validator sets are the same, then you just look at the commits, and you look at the intersection between the trusted and conflicting, because these are the processes which sign different blocks. So if you are part of commit, you sign pre-commit for A and you sign pre-commit for B, and you're bad. And so it's very simple, it's straightforward to define what are misbehaving processes in this case. Okay, and in case of amnesia, the problem is, so here let's say the theory is a bit more complex, but the amnesia attack are, and let me also define what is meant by amnesia attack. So if commit round is not the same, this means that attack spreads between multiple rounds. And if attack spreads between multiple rounds, then I mean, these are kind of the claims for which I don't have necessarily maybe, let's say, or kind of theory written up, but if there are two conflicting blocks with the same validator sets in different commit rounds, it must involve amnesia. You cannot do attack with the conflicting commit rounds if you don't involve amnesia. So some faulty process need to cheat by locking one value or pre-committing one value and then changing its mind. And we don't say here that you will have more than 1/3 of such guys. There are amnesia attacks which involve one how we call it, Joseph, amnesia. I don't know how you use that. I don't know how to pronounce it. Amnesic attack, and the rest is just equivocating. But there is at least one amnesia guy, and if you don't do this full fork accountability procedure, will not be able to detect.
Zarko, why do you ask me? There are at least 2 native speakers here that should be able to help us with
Yeah,
it.
because you invented this term.
Honestly, as a native speaker, I had to think about how to say that word too. So you're really doing an A+ job choosing difficult vocabulary words.
Did we invent a word, amnesiatic? Is that a mountain range near Zurich, or a Byzantine fault tolerant? I don't know.
Amnesiatic fault tolerance.
Yeah, it sounds really sophisticated, and it is. It's like,
We should publish a paper.
yeah. So this is essentially
Okay, so just to zoom out again and make sure I'm sort of following where we are in this like evidence handling journey, right? We sort of talked about like the kinds of attacks that can happen. We talked about the light client bundling those sort of like evidence objects up and passing it back like over to the witness. And then we talked about like the witness using those evidence objects to like construct, I guess, more full-fledged evidence objects that contain validators, checking the bonding periods, doing all of that stuff. Like, where are we when we talk about, you know, and then we were talking about like pure equivocation attacks and amnesia attacks. Are we still kind of in that part of the process where the witness is like constructing fuller evidence objects, or have we like moved on to the next phase?
No, so essentially I would suggest we zoom out again now and we start from the beginning, but we now kind of define the terms.
Okay.
So the light client is defined by these 2 conflicting traces. We talk about light client and 2 peers, and they're having these primary witness roles. This is the data structure which capture the attack, and there are 3 kinds of attacks. Mm-hmm. And we covered what we consider a valid light client attack evidence.
Mm-hmm. And one more terminology question. The concept of a trace is now confined to the light client, right?
The trace is essentially
it's a set of headers that it follows.
Yeah, it's more or less like the trace as a term somehow disappear in the slightest proposal.
Right. So that's what I'm just trying to understand what we're like. What's up with traces? Basically, are we constructing them at the light client, passing them around? Is it something the light client checks when it's building this evidence object, and then like we don't talk about them anymore?
They come from the light client. The light client follows a path to get up to date, and then it tells people its path. It says like, "Hey, I saw something wrong." Like, but how'd you get there? Well, let me tell you. That's a trace.
Well, yeah, that's what I'm asking. Is it still passing the traces around or not anymore?
No, it's not. It's not. That's
okay, that's what cool.
Yeah, because the light client attack evidence doesn't have a trace. It has one block, it has one integer, which is a height, and it has a type. And this is like, we claim that this is a minimal, it's sufficient information in this light client game so that receiving node can validate and say, yeah, this was indeed attack.
Okay, fantastic. Just checking.
Yeah, but this is very important. So yes.
I don't want to make things more complicated, but it will be slightly different with IBC.
Yeah, but we don't want, yeah, but like, don't do this now. So the light client is it's not more, let's say, significantly more complex, but it's not so simple there. Yeah. So now, how we build this and where the trace comes from, just to answer to this question. So when now, let's say that we are in this game where light client talks with the primary and witness, and it verify a block with the primary, and it check with the witness the header for the verified block, and it sees something different there. So like if you graphically look this, we are in this, we started from 1. On a primary, we are trying to verify 10, and so we are going over 4. We have 1, 4, and 10. This is what we call primary trace. And now we go, we ask witness, what is your header at 10? And witness said something completely different than what we have here. At that point in time, so this is all happening at the like line. At that point in time, we start this procedure here. And this procedure, which involved, so like line will actually talk with the witness, and it will try to detect whether this was indeed attack, and it will build this like line attack evidence if there was attack there.
Okay, cool. I'm not sure we need to go into more detail. I know we kind of went over this stuff already, so I don't know that we need to go into more detail about how the traces are built. I just wanted to know like what the scope was of the traces. Like, are they confined to sort of this first process and only the light client thinks about them? Are they passed around? And I think we have the answer to that question.
The only important thing here is that we'll do this twice. So
Okay.
we'll do it for the primary as a suspected party and witness as a correct one. So we can build evidence for witness, and then we'll swap the roles, because maybe you know the witness is faulty and the primary is correct, and so we'll try to create the like line attack evidence with suspect witness, and this we'll do by starting from the trace we obtain from witness by going from 1 to 10 and considering this as a primary trace, and then talking with the old primary, which now act as a witness, to build the like line, the minimal like line. And this is captured now in these. So this detect like line attack function has a trace and a peer, and it will do what we explained before. And so inside the detect like line attacks, we are actually doing this twice. One where we have initial primary trace and the witness, and then we swap a role, and then we also try to build evidence for the other one. And so why this is important? First, because we are kind of primarily interested in a case where primary is faulty, and then witness is correct, because this gives us possibility to detect that some information which we want to provide to the end user, if it was wrong, we want to kind of detect that it's wrong. But we also want to disincentivize bad guys to just send us forks, because if we don't punish this, they will just shut down the like line all the time, and they will not be penalized for this. So that's why it's important that we also try to build the evidence for the case where the primary is correct and witness is faulty. And so here, just important thing to keep in mind is that we'll manage to go through this process only if the full node is participating. So if a query full node doesn't come back, then we cannot build like line evidence, but then we'll disconnect anyway from the guy, and we'll kind of ignore it. Then it's not really attack. So so essentially now if we again zoom out a bit, we have a like client, there is a primary and witness. We are doing this game of building like line attack evidence, which looks like this. And after we create such evidence, we'll submit it, like in some cases only to the correct witness, in some cases to the correct primary, in some cases both to witness and primary, because they are cooperating with us. Okay? And now when the like client evidence is received by the full node, we'll do the following. We'll check whether the like client attack evidence is valid. And so this is what the full node will do. And then it will, if I'm not wrong, as part of the evidence reactor, it will then keep disseminating it through the network. So Caleb, you can maybe jump here just to clarify this. But my understanding is that when we receive the full node like line attack evidence as part of evidence reactor, we check for validity, and if it's valid, we keep disseminating it in the network. Okay. And now eventually the evidence will it will reach validator, which will propose a next block, and it will include the like client attack evidence there. And if the block is eventually, block is confirmed and executed, and then what we need to do before talking to the application via ABCI, we need to execute these evidence handling functions, which are, depending on the attack type, outputting the validators slightly differently. In case of lunatic, it's straightforward. It's like its case of equivocation, it's straightforward. In case of amnesia, we need to do something which is more complex.
And do these evidence handling, does this evidence handling logic get executed before or after the evidence is committed to the block?
My understanding is that it's executed after it's being committed to block.
Okay, cool.
As part of, but this is what Calum explained me, and I don't know whether I got it correctly, but I understood that evidence validity is checked before block is committed, but then execution or evidence handling takes place after evidence is committed to block.
That makes perfect sense to me.
Yeah, it's in the apply block. So there's a function that the block executor runs after it's been committed on the chain to then apply it, and it involves sending evidence to the ABCI.
And how when the block is being proposed, I guess that as part of the block validity, we'll also check for evidence validity. So this essentially, if some validator include a like client attack evidence, then this isValid function should be executed by correct validators when they receive such proposal. So they should not pre-vote for it if it's not valid evidence, because it's also not valid block then. Is this correct or? Okay, cool. And so now let's say that the last piece of the evidence handling puzzle is the amnesia. And so in case of amnesia, we have this multi-round attack, and in order to detect the misbehaving nodes, we need to have access to the vote sets of at least all correct validators which participated in that height. Therefore, and the way how it works essentially is that we consider a trusted process, which we call monitor, which will collect those vote sets, and then it will do the processing, which is described here. And at the end of this processing, we have a list of misbehaving nodes. And so there are several sort of preconditions here. The first one is that for multi-round commits or heights in which we have multi-round commit round is greater than 0. So we have multi-round instance. We expect that the validators will log all votes for all rounds in that instance which were received and sent. So these are essentially I think it's called height vote set. And so height vote set in this case should be persisted. And so for all instances within unbonding period, we assume that to support amnesia, all multi-round instances should persist height vote sets. And then after amnesia attack has been detected and committed on chain, we assume either, let's say, off-chain monitored process, which will be trusted, and which will essentially have access to those vote sets. So it can pull, we assume that there is an endpoint on which you can pull for these vote sets, and then there is a bound in time after which you finish collecting those vote sets, and then you run this logic here, which output the misbehaving guy. If we run this on chain, then we would need to somehow, the monitor would be the on-chain process, which essentially orchestrates this. So after amnesia evidence is committed on chain, we'll start a timeout, and so suspected validators will need to provide their vote sets during this time period. I don't know, either committing them on chain or like writing them to some, I don't know, for example, IPFS, and then have the commitment on chain. But they need to, in a bounding time, if they are correct, they need to provide their vote sets. And then after this time period is over, then we run this procedure on chain, and then we output the vote sets. Now, who would do this? Whether this will be executed as part of Tendermint or as part of SDK, we never sort of, we never build agreement around this. But somehow, if we want to really punish misbehaving node in amnesia case, we need to have this procedure run by someone we trust, either on-chain or off-chain.
Right, and I think we've decided to sort of punt on that decision, right? And we're saying for now, we'll just record, this evidence in the blockchain. We'll validate it and commit it, but we're not going to do any of this handling piece.
Yeah, I think that this makes sense because it's just important that we have the procedure and we are essentially communicating clearly to the validators or in general the community that in case of amnesia attack, we have a procedure which can be executed. And right now it probably involves off-chain process, someone, picking this evidence, trying to collect stuff, execute procedure, and most probably as part of the on-chain governance, create a proposal to punish misbehaving guys.
Cool.
So I think that this is, but we will, I guess the idea is that we are not ignoring this, because ignoring the amnesia is essentially open the possibility to do attacks, also on IBC, which if you don't punish, then we are disincentivizing this behavior. So
is it very complicated to determine whether an amnesia attack happened or not, because you have to scroll through all the vote sets?
No, actually, maybe you missed that part. So given light client attack evidence, we know exactly whether it was lunatic attack, equivocation, or amnesia, just by looking at the conflicting block and a trusted block. So if essentially for amnesia attack, it needs to have these two blocks, or conflicting block needs to be valid. So it needs to have these valid validator set hash, etc., other fields which are output by application, and it needs to be, the commit round needs to be different in this.
Yeah, exactly. But I guess if I'm a full node, what data, what is the input to me determining whether amnesia happens? So someone gives me evidence, which is like partial information, but I have like a block history, and then I could actually, is it so expensive that we don't want to do it regularly?
No, what we do actually, we always check for it, and we'll write it as part of evidence handling. We'll probably write it on chain and say, there was amnesia attack. And these are we could say, although this information exists on chain, we know what was the validator set which was involved in that instance.
Yeah.
We know the suspected guys, but right now we just don't we don't do the handling or punishment on chain.
Yeah.
We expect that someone will do it off chain. But the own information, you have enough information to know on chain that there was amnesia. Yeah. There was amnesia attack. And this is cheap. And we are doing it for now. And we also are persisting the votes, height vote sets, so someone can do this computation off chain.
So it's like the sentencing process, or the actual like doling out the penalty, that is left to a governance process.
Yes.
But the not abdication, but the conclusion, the jury is out. We know it happened, and that's on chain forever.
Exactly.
Okay.
I think it's a reasonable, it's a trade-off, but I think it's a reasonable trade-off, so that we are saying, okay, it's a bit complex now, and so we don't want to implement it on chain, but we are not ignoring it. So we are recording that it happened. So all information which are needed to actually do the amnesia evidence handling are there. It exists, it's committed on chain, and you can fetch it, and then you can proceed using governance to punish misbehavior.
Very cool.
I think that's a totally reasonable and pragmatic trade-off to make, especially given kind of like where the SDK team is at with this stuff and what they're thinking about actually handling and implementing. Cool. This has been so far, like by far the most helpful conversation for me in terms of like my understanding of how all this stuff works. This was really, really helpful. I feel like I finally have my head around light client attack evidence handling like for the first time. And that's very, very exciting for me. So thank you so much for that. Are there other parts of this process that we haven't discussed yet that we should cover, or should we switch over to the RFC piece?
No, here it's more like a question like, are we sort of fine, in this group to proceed with this proposal and essentially to go after both on implementation side and spec side, trying to wrap this up, or someone is still like not convinced of this proposal. So there is a PR open, so of course, like feel free to make comments there.
I mean, I'm sold. Anton, what do you think?
Yeah, proposal is good. Unfortunately, it will take a lot of work to kind of rewrite the Tendermint part from handling like this individual pieces of evidence to this generic evidence. So I'm not sure if it will take how many hours it will take, but it will be more than 1 day for sure. Yeah, I also have questions, but we can discuss it in the PR. So like I still don't understand why we need the type field, like because it can be deduced from the conflicting block. So
Yeah.
Like when we're handling this evidence on the full node, we're essentially checking what type of evidence this is, like a measure or like evacuation, or so like we can do it ourselves. We don't need this type byte field or whatever 1, 2, 3.
Mm-hmm.
I agree. This is true. So we should probably, it will also simplify a bit, I guess, logic, because then
we can create a private field which will be used for like, I don't know, string representation or whatever, but I don't think we should like send it across the internet.
I agree. That's a good point.
Also like I have doubts about this measure handling. It wasn't like, to be honest, it wasn't working with the I don't think the columns implementation was like a 100% working solution, because first of all, there's a problem of blocking the evidence from being committed. So if bad guys have more than 1/3 plus of total voting power, they can just block or how to say filter the blocks, prevent blocks from being committed with this evidence. That means, but actually in Calum's work, what happens is when the node receives the evidence, it starts this process immediately. So this may actually work. I don't know. Actually, it was a very good implementation. Maybe we should like reconsider it.
No, but
And the problem with governance is also like for governance proposal to pass, you need a certain % of voting power. But if the bad guys have vote like hard no to proposal, then it won't pass, of course.
yeah, true. So I think that ideal solution is that we have this on chain, and so if you talk about this column implementation, the one which is captured by the ADIR 65, if I'm not wrong.
Yeah.
Yeah.
56. Other way around. Yeah.
56. Okay.
Yeah.
There is there are essentially some just the conceptual problem there. I think we are not able to catch all misbehaving nodes, because you can, if you only essentially talk to one guy and you are kind of faulty, and then this guy needs to build the evidence that he's not wrong, he can always cheat you by doing this if you don't cross-check this with the other guy. And that's why we need to sort of collect this information at one place and have somehow the global view on this thing. This is the data set on which we make decision who was wrong in this amnesia attack and who was not. And that's a problem. So now how costly and complex is to implement this? It's I don't think it's very complex. It's probably similar to that implementation. It's just, I guess it's a matter of like time and priority.
Yeah, that's the problem of trust. Like what is this trusted Oracle? Like I don't trust anybody. So, well, but what if we gossip? Like say any node acts as a Oracle and requesting this vote set, like any node. And when I receive vote set from a node, like I record it, I like form some kind of evidence, and then I gossip it to other nodes. So like I have this saying like I have this evidence. Like I ask node 1, 2, 3, and I myself form this evidence. Check it with you, like.
Yeah, I mean essentially the part,
1, 2, 3, and
the part of the problem here is that we need to have the process is like inherently synchronous. So we need to define this challenge and say, now you have 2 days to submit the vote sets. And after 2 days, we all look at the same data and we decide who is correct and who is not. So if you have the partially, at least with the current implementation, we are not able to do this on a partial information. So if you're
because we don't have a common view.
We don't have a common view. Yeah, that's a problem. Now maybe so there is probably more efficient way to implement this, or there is a smarter way to implement this on chain. We just haven't this worked out. I think this is a partial problem. So the kind of the proposal which we have written here is just a kind of, let's say, conceptual set of steps. But what is really the efficient way to implement this on chain? We never actually did this exercise. And so like, I think that it's sort of really, we probably don't have time to do this before Stargate. We could try, but we need to sort of figure out what is really meaningful way to implement this on chain. And because we need to be careful, as the vote sets could be potentially quite big in size. And there are like trade-offs there, like, do we want to commit those data on chain so that it's really, as you said, like you don't trust anyone else, so that how we build this trust that this is the vote set on which we are running the procedure. And also we have some sort of proof that the time has passed and people haven't committed their vote sets there. So there are a lot of question marks there, like how we would really be fair, having in mind the censorship potential of the guys who actually misbehave, that they would try to block this. So.
Okay.
Yeah.
I have one more question. What is the expected behavior from a node which encounters this amnesia evidence? Does it stop, or like it will certainly try to commit amnesia evidence on chain, but what I'm saying is there is a high chance it won't happen because bad guys will prevent it from being committed, prevent a block with this evidence from being committed.
Yeah, this is actually a very good point. So go ahead.
Like, do we stop this node?
Yeah, I think that this is something which we could also do as part of this short-term implementation, that for both equivocation and amnesia, I mean, even for lunatic, like the guys who are who are, let's say, accused, they might try to censor the evidence because they will be slashed. So maybe we want to add as part of evidence reactor some sort of some kind of mechanism which, after seeing valid like line attack evidence and then gossip it around, if it doesn't see it committed to a block within a period of time, it will halt the node, and like let's say on some API, the state would be, I saw evidence which hasn't been processed, so I refuse to participate in the network anymore.
Right. Or just like keep trying to only basically accept blocks with this evidence.
Exactly. This is alternative. Exactly. So after, let's say, after I see evidence, I give some time to the network to disseminate it, and then after this period is over, I only accept block with evidence in it.
Yeah.
And so I think this is very important. So this is really, I think, a good point. And this is not a case we halt.
Yeah.
Right. Yeah. That's why I was asking.
That's a very good point. Yeah.
Yeah. Okay. Should we move on?
Yeah. Let's get that last part like written down somewhere, like in this spec or in an ADR or something. But yeah, I mean, I was actually going to ask, like, if there are, if there's enough material here that we should say, oh, we need another follow-up call to discuss these sort of like details and finer points, Anton, that you're raising, or if we have enough confidence in this direction to proceed. Like I said, I'm like this current approach. It feels simpler to me. I can understand it more thoroughly. It seems like something that would be like a solid foundation to like build refinements on top of if we need, which I like. But Anton, if you or anyone else on this call has doubts or concerns, we should continue to have those conversations. So that's.
I think it's more about follow-up, and maybe Anton, what we can do, we can try to organize a brainstorming session and to sit like in a smaller group and to try to come up with a kind of requirements for this on-chain solution, and just to try to sketch how it would look like, so we have it somewhere, so it can be planned, and then when we have resources, we can go and spec it and implement it. So
yeah, that would be great.
Okay, so then if you agree, I can try to organize this, and so we just more or less, we don't leave it completely open, but we say now, this is what we implement right now, and then there's a clear roadmap with more or less a high-level sketch of the solution, which we'll leave somewhere on the GitHub, so that it can be taken from there and implemented when I have resources for it.
That sounds like a great next step to me. Okay, I do now want to move on to the RFC stuff, because I did kind of rope Sean into rejoining this call to talk about it a little bit. So Sean, the context, the question I raised earlier before you joined was just like, we say we have this RFC process, we mention it in the contributing guidelines, we tell external contributors, hey, you want to make a change, start by opening an RFC. And I realized that I don't think we actually have like a real RFC process or like protocols around it in terms of like who needs to approve an RFC, when is the actual comment period in the RFC, is it when it's the RFC is still in PR phase, is it after it's been merged, do we have a process for actually like sending these things out and actually soliciting comments? Honestly, just like so many questions, and I think you may have introduced this or at least advocated for it, and so we were wondering if you could just share your thoughts on it, if you have experience running other RFC processes, just like catch us all up.
So first of all, are we going to record the whole thing?
Yeah, this I'm also wondering.
I can stop the recording now.
If we wanted to focus on the evidence handling, I thought
I mean,
we can include this as well if people.
I think it might be interesting. I mean, we sort of have been recording these things like just the whole meeting, more or less. And yeah, but if there's anything sensitive, I can stop it and cut this little piece of the conversation out.
I feel very sensitive, but also comfortable. So we could just proceed. Okay, so first of all, second
Wait,
of
do you
all,
want me to stop recording or not?
no, we can record it. It's great.
Okay, okay, just checking.
Fantastic.
Okay.
Okay, like most problems at Tendermint, this was, of course, outlined by Marco, right? Like Marco wanted a request for commenting, and at first, as usual, I ignored him, but then I thought about it a little deeply, and it made like a ton of sense. So now I'm very pro RFC for cases of which problems are badly defined. So if you look, we have this flow chart, like just to say where this is coming from. We have like, there is an issue, and maybe we understand the problem. If so, then also maybe we understand the solution. If so, then we can actually start implementing it. But sometimes we actually don't understand the proposed solution, right? Which is why we do this ADR thing to like de-risk complex solutions, to make sure that we don't have like this huge PR that lands like after a month of work and then no one can review it, right? So you're trying to build consensus over a solution, but sometimes things are really complex, and you need to build consensus that something that you think is a problem is actually the problem, and you framed it the correct way. So I don't think we do this very often. I think that we kind of naturally, I guess there's so few resources familiar with like what problems people are solving, that we tend to just like rubber stamp and say like, hey, I'm so happy that you're actually going to try and make something better, that I'm just going to like support, which I think is fantastic in many, many ways. There's a few key ways of which it's terrible, in that there's like incoherence in the implementation, and sometimes we have to implement features. And I would attribute that to like misunderstanding of the problem. So I'll give you an example. The example that I'll use is like, we have like nodes that do different things, but they kind of do and they kind of don't. Like we could turn certain things off, then we could advocate for other things being on. And then we have this problem that different people use different nodes in different ways. But like, given a node with an IP address and a port, what does this thing do, right? That's some people's problem. Another problem that people have is like, oh, I'm a light client, and apparently I need these RPC endpoints. Where do I get RPC endpoints? Do I need a website or whatever? So we could solve this problem in any number of ways. One of the ways we could solve this is say like, just don't use RPC. We will implement a whole reactor just for you. We'll just make sure that the IP address, the configuration information that you use can scale to any problem that you want to solve, because we'll kind of like, we'll do this for you. That's one solution. I think that this solution comes fundamentally from a misunderstanding of the problem. The problem is not that RPC endpoints are hard to find. The problem is fundamentally that our software has reached a point of complexity where it's heterogeneous in a network, and this has many touch points. One of the touch points is what I'm calling service discovery. Another one is Tendermint modes, so on and so forth, right? So the whole point of the RFC process is really to surface these formulations, say like, hey, I think this is a problem. Have I framed it correctly? And said another way is, sometimes when someone says, hey, I want to do something, I think that we should do this thing, I think you could challenge that and be like, frame the problem. Tell me what it is, like, and say how you think it in a more collaborative way. So the difference between like an RFC and an issue in my mind is one of them has like a high degree of confidence in how it's framed it, versus when you go through the process of writing an RFC, you're kind of open to this idea of like, maybe I'm wrong about how I've framed this, and that here's my reasoning. I'm going to build up an argument, you know, at any which point something could be wrong, and I'm totally down for that. And so that we could kind of find where in the stack maybe things have framed the wrong way. Like, is there a problem that RPC endpoints are hard to discover? 100%.
So maybe another way of describing where the RFC piece fits into sort of the overall like development process is like, issues should surface problems. RFCs should attempt to agree on like a high level direction or like a general solution. And then ADRs deal with implementation details and other like design decisions. Is that a fair distinction? I guess one other way of asking what I'm asking is like, where do you draw the line between RFC and ADR?
I think you draw the I think that's a really good point. It's actually the hardest thing to do. Out of all the things that we mentioned, right? Writing an RFC, because it requires a certain intuition that there's like consequences to certain decisions of thinking.
Mm-hmm.
Like if you frame the problem this way, you'll, implement something that will have a maintenance load, or
Yeah,
that
I mean,
performance consideration.
my guess, without having ever really participated in RFC processes before, is that RFCs should be short and fairly concise in a way that like anyone can jump in, take a look at it, and think like, oh, this is going to impact me in the following ways, or this is going to impact my project in the following ways, and I want to weigh in. And it's like an opportunity to invite people. Like literally, it's like a request for comment.
It is a request for comment. And specifically, I'll give you an example. State Sync required an RFC. This is actually this is Marco's great idea. When he was looking at this problem, he was talking like, oh, we should do this thing. I was like, yeah, let's do this thing, but it seems badly framed. And then you had a bunch of people try and write ADDORs and fail.
Mm-hmm.
And that was because the problem was not well defined. There was too many assumptions and misunderstood axes that created different like positions in the solution space. So we needed to take a time to like frame that, and this is when we did this like eager versus lazy and blah, 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 and looked at it like a whole bunch of different ways before.
I have a question which is not so clear. So somehow the discussion started with, we want to be more inclusive in people contributing. But now the difference between RFC and issue, as Sean describes it, leads a lot of insight. So is it sort of the people we would try to address, are they able to make the distinction between an issue and an RFC?
I think it's super tricky, and I think Tess is what I'm understanding from what Tess is saying is we need to simplify this. So I'm hoping like at the end of this conversation, we'll have scoped an RFC to answer this a little bit. I think that it does suffer from being overly broad and that it's being less effective. But I'll give you an example. Like someone says, let's do BLS signatures. Okay, this is high level. This makes sense. Okay, but what kind of, one way to solve this was an ADR, but like, is there any alternatives? Like maybe we all agree and we all know BLS is great and, whatever, but maybe there's certain trade-offs there. Maybe the signature is like fast to send, but harder to verify. That's actually not true. But if it were true, these are the kind of axes that you would want to surface in an RFC process. Because it's like, you don't like, say there's like, sorry to make this so complicated, but we'll try and simplify. Like a technical solution usually has multiple dimensions, speed, complexity, impact, engineering impact. Like if someone just says like, oh, here's a solution, they're a point in a solution space that maybe everyone understands, but also maybe we don't. So an RFC is really about, or the places where I've seen it be incredibly useful is in determining where on the grid we want to invest energy into.
So I think if I were looking for like a takeaway from this conversation, or a takeaway from understanding the RFC process, one thing I'd be looking for, one indication that we would have figured it out would be like, okay, we would know what to do next with two of the RFCs that are open right now. One is ZIP 215, which is this like curve, Ed 25519 curve update that the Zcash folks have proposed to like standardize signature verification across different languages. And the other is this, what is it? It's the proposer quark chain thing, right?
Yeah, I think that one. Oh, sorry. I'll let you finish before I jump in.
Well, I was just gonna say we have two open RFCs, and I don't know what to do with them. Right? I'm like, who needs to sign off on these? Should we publicize them? Did they write good RFCs? I have no idea.
I think.
Sorry. Go.
But no, go ahead, Marco, please.
For the quark chain RFC, I don't believe it's a full RFC because it's the phase 1, 2, and 3 are more implementation details, while phase 0 is the actual is the only thing that would affect multiple clients, and that is the check TX priority. And so at least when I was speaking with them, I asked them to first open up an issue before they spend time writing out an RFC, because I do believe, at least how I approach it, is like we first open an issue, and then like kind of basically how Sean wrote out the diagram was an issue, and then if there's some sort of, if there's not enough clarity between the teams on like what this impacts and what changes need to be made, then it's okay, we should do an RFC so we can better understand where the impacts will be in the application and also in the clients, Tendermint Go, Tendermint RS. And then at that point, depending on the clarity between the clients of Tendermint RS and Tendermint Go, they can decide if they want to do an ADR or not, is kind of like the approach I've been taking.
Yeah, I think that makes a lot of sense. The one thing that I would add is RFCs should ideally be pinged or triaged quite quickly, and then have a timeout. You have 2 weeks to get your comments in, like, and then it's gonna go through. So maybe we could have a template that says like, what do we want? We want decision. What do we want? Well, like axes, like trade-offs, like enumeration of trade-offs, and then suggestion of a position, like in the RFC. Like here are the dimensions. I think speed is important more than efficiency. And then here's who I need to do it. Like I need Bucky and Zarko to sign off. Bucky and Zarko have 2 weeks to say no, otherwise it goes through, or some reasonable timeline. And then the people that are sort of tagged in it, they could have a response that would delay. So they could say like, this is what I think, or whatever, I need another 2 weeks. But the idea is if they do not reply, then it's automatically accepted, so that things don't linger.
That implies that once an RFC is merged, it's been approved. Is that right?
Yeah. As in that the trade-off has been like accepted, and then any changes are going to have to be a refactoring of that. Is that crazy?
I don't think that's crazy. What I'm realizing from this conversation is that we probably need to, sort of in the same way, Sean, that you wrote the contributing guidelines at a high level, we may need more, and also in the same way that we have documents that outline sort of what makes a good ADR, what the purpose of an ADR is, we may need something like that defines the RFC process and defines things like these timeouts.
Just quickly, just a template maybe. Would that be enough?
Sorry? Would
a template be sufficient, or?
I think a template is a really strong start. It may need more explanation on like, are things like timeouts obvious from a template? I don't know.
Yeah. So just to phrase, okay. So I'm trying to simplify this.
Yeah.
The point is that like everyone's contribution matters. People should be motivated to contribute, and they should have high confidence that the energy invested is going to land on master. As maintainers, right? We could put some barriers to entry, but they have to be reasonable, right? So this is a maintainer tool to say that I need like an audible history of technical decisions of like, even if I don't like it, it's not about getting like the perfect solution. It's about getting an audible like set of solutions so people can trace the thinking, so that if the thinking is wrong, people can like fix it faster. So it's okay if it's not supposed to produce like, the best thing. It's supposed to be a well-motivated thing. So we should give contributors this confidence that like, if you do this thing, it's gonna land. Both like if we agree that the problem is a problem, like you've made your case, and that your purported solution in the ADR solves the problem, the PR and the PR adheres to our standards, it's going to be on master.
Yeah. So I really, really agree with these goals. I think these are exactly the right goals. And I think that we have the right high level approach to get there and to make that happen. I'm just not sure that we have the details ironed out to actually like support people through the RFC process,
I think we could probably brainstorm a couple tenets of what we would want from an RFC that could go into a template, and then a minimal process that says timeout is 2 weeks.
Mm-hmm.
You have to tag a maintainer,
Mm-hmm.
and if they don't reply, it's going to get merged, or something. That would be the minimal set.
Okay. Yeah, that all sounds, the merge by default thing, I'm going to push back on at some point, but I think what I'm taking away from this at this point is that we should get a few folks together who are, excited about this and passionate about this, to figure out how to write that document, what the tenets should be.
So Anton, as a maintainer, does this scare you or excite you? Or none? It's just another stupid thing that we do. What are we talking about?
Just another process that the engineering managers have implemented.
But I guess that somehow what would be the change with respect to the current process is that we commit to address external contribution within a time frame.
It's like it's a tool for maintainers to say, I'm not ready to help you. If you do these things, like I don't know if you've stated the problem correctly. Like in the issue, it isn't clear what the problem is. I need you to write an RFC. If you do that, I'm committed to helping you. So this is like a protocol thing.
Yeah, but like what I don't understand is, after, let's say that RFC it describes correctly the valid problem, and now how we decide whether it's how relevant this problem is to the community, and also like, do we commit to work on it, or this is more like a process for external contributors to like initiate the problem and then to be followed in creating effectively the PR.
It's a pathway to master for external contributors.
Okay. And we just commit that we'll provide the guidance and we'll be following the process.
Yeah, it means that we're not gonna like make a huge fuss and give like, oh, I'm not like, we're not gonna ignore it or say like, you're not gonna do a huge PR and send it, and then people are gonna say like, give you lukewarm response and be like, maybe no, like it's trying to save contributors time and also reviewers time.
Yeah, it's like a way of trying to find alignment at the beginning of the process rather than the end.
So when the RFC lands on master, is it then going back to an issue again, or what is the plan then?
Means the person's probably going to propose an ADR.
Okay.
Right, but we should write all this stuff down and like agree on all this, because it's not obvious.
Oh, sorry, that's not in the flowchart?
Well, it is in the flowchart, but like I still don't know like at what point is the RFC. It's not, what is not in the flowchart is like, what does it actually mean when an RFC is accepted? Like, is it when it's merged? How many people have to approve an RFC? So on and so forth. There's like stuff like that that's just missing from the flowchart,
Yeah,
which is fine. It's not a problem. We just need to get it sorted out at some point.
So I guess, the best thing that you can get out of an RFC is like an ADR, which you're then on board with. So you get an ADR and the solution is actually solving a problem that you agree with,
Mm-hmm.
Yeah,
Go
ahead, Marco.
Just kind of taking one step back is like, depending on the implementation, this may be something we run into sooner than later, or it might be in half a year, is if a Rust contributor comes and makes an RFC on the spec repo, then they are willing to do the contribution on the Rust side, but then the Go implementation won't be able to be kept up with it. And so then this kind of yin-yang, kind of going back and forth comes into play. And so this is another consideration that we should take into account.
This is a really good point. So like, say you want to change the protocol. You want to like add like a hash of evidence or something crazy like this. I don't know how crazy it is. Need an RFC. Okay, but say you're proposing a change to the core data structures, right? This is exactly why you would need an RFC, and there would be a Go person and a Rust person. So even if it's proposed by a Rust person, it's a protocol thing. So what I think,
Yeah, this is exactly the kind of thing that I'm wondering about. Like, who needs to approve it?
We talked about this.
Yeah.
How to govern the spec repo. I made a proposal, but yeah, we just need to, we're going to assign some people. There's like a code owner's file, and hopefully that's going to be a little bit precise in the different sections. But this is, it's going to be a list of stakeholders. So maybe it's overly broad now, and it's going to be a little bit painful for the people on that list. But it is what it is. The point is that if your implementation is not going to be able to adhere to the spec changes, that is your point to voice that, is to say it doesn't make sense for us, maybe later, doesn't align with our roadmap. That's where that's going to be, that's where those realities are going to get surfaced.
Right, but this is a good point too, because it's not as straightforward as just saying like, oh, this is just a path to master for external contributors, because there may be actual implementation work that's required from, you know, core maintaining teams if we're trying to like keep parity with the implementations, for example.
So master, so one day soon, the spec is going to be versioned.
Mm-hmm.
So,
Mm-hmm. That would be great.
Okay, when the spec is versioned, master means proposed for the next version of the spec.
Mm-hmm.
And then the implementations are going to decide when do they implement that version of the spec.
But does it make sense to also have RFC for just a given implementation?
Yes, for the same
And
reason.
so like RFC can be inside, if it's for a protocol change, then it's RFC as part of Tendermint spec repo. And if it's RFC for a change, like you wanted to add a feature to the Go implementation of Tendermint or Rust implementation, then you go to that repo and then you create directly RFC there.
Non-protocol breaking changes can be repo specific and governed by those teams,
Okay.
like anything else. But sometimes, like even a small change, say like, hey, I think this is faster. Here's why. I think this is a performance benefit. Here's how my reasoning. Like, if you get a huge PR and you don't know like the trade-offs that someone's made, chances are it's going to get rejected because it's too nuanced, you know, and that's not fair.
And also I have one let's say last question. Let's say that RFC defines really a valid use case or valid feature or a protocol change, whatever. So we sort of approve this. We say, yeah, this makes sense. And then there is ADR, and ADR potentially makes sense. But a PR or suggested solution is not up to the Tendermint standards right now. Like, do we have a problem in that process to say no to the implementation and
we should exactly. This is a perfect question, because then we're saying no to the implementation and not to the idea. It's not that it's not a good idea or the problem is not well framed. It's just the implementation. So fix the implementation, not the problem. Or maybe someone else comes in and solves the problem better. I don't know.
Yeah. Or ADR, like ADR could be wrong. Maybe the solution is, the problem is fine, but the architecture proposed is not what.
Yes,
okay.
Precisely.
Okay.
Okay. So I think as a next step, it would be nice to have some kind of proposal for what this process should look like, sort of like the flowchart and the contributing guidelines that already exist. My instinct is that Marco and Sean, the two of you, would be the right people to take on putting that together, just because I think you two have the most, have like done the most work in this area and are the most passionate about it. But if anyone else would like to contribute, or if either of you are like, absolutely not, I'm not writing that document, we can figure something else out.
What do you think, Eric?
No, I think it makes sense. Absolutely. So if my understanding is correct, then sort of the RFC would be a tool for sort of exploring the solution space, and the ADR would be for actually sort of recording the decision and the plan for implementation, right?
Exactly.
That makes a lot of sense to me.
Okay, maybe next week. Maybe next week. Is that okay? Is there a rush on this? There's no like. Let's just make sure it gets done.
Yeah, I mean, we will want to make a decision on these outstanding RFCs, but they don't have to follow the formal process. We can just YOLO it.
And also, I'll be opening the inaugural RFC for Tendermint repo, like in a couple of days, because I'm working on a proposal for the end-to-end test suite, which I guess sort of belongs as an RFC in the Tendermint repo. So I'll
Sweet.
get it up.
Awesome. Whew, all right, right on the, well, not quite right on the dot, but almost right on the dot. So